My name is Karthikeyan. I'm from CII Godrej Green Business Center. It's my pleasure to welcome you all for this webinar. We have Mr. Ludwig from Swedish Energy Agency. He'll be speaking to you shortly. And we have Mr. Klaus Stahl, Chairman and Managing Director from S-Solar, and Mr. Georgios Fofas, Senior Business Developer from Excelsior. I welcome both the speakers as well as the participants for this webinar. Before getting into the webinar, it would be my pleasure to introduce about our initiative on Innovation Accelerator. That is something CII Godrej Green Business Center with the support of Swedish Energy Agency and Embassy of Sweden, Business Sweden has taken up in India. The main objective of this Innovation Accelerator is to identify innovative Swedish technologies and facilitate the technologies transfer in the clean tech area in India. So what we are trying to do, we are trying to take many initiatives in terms of understanding the requirement from Indian side, identifying the relevant technologies from Sweden, and then introduce them to the Indian companies. Even we facilitate a kind of business-to-business interactions, facilitate business tie-ups that could happen in future. So as part of this initiative, this webinar has been organized. In this webinar, initially the presentation would be made by the presenter one by one. The first presentation will be made by Mr. Georgios Fofas from Excelsior. So immediately after the presentation, you can start entering the questions, whatever you want to ask, especially from the participant side. So the questions would be read out by my colleague, Ms. Prasanna from Green Business Center, so that the speaker can answer all those questions. The same procedure we will follow for the second presenter as well. The another part what I would like to highlight is all these discussions and presentations are being recorded, and this would be uploaded in our Innovation Accelerator website. So I would request you to register yourself as part of this virtual platform. You can download the presentations, and you can also look at whatever the kind of discussions that had happened during the course of this webinar. Friends, as part of this initiative, we are also looking at a business-to-business meeting. Education is planning to come from Sweden to India in the month of April. So during April 23rd to 25th, we are planning to have the meeting in Mumbai, and 27th to 29th in Chennai. So I would request the participants to block their diary depending upon their convenience to meet with the Swedish delegation in India. So now I hand over this webinar to Mr. Ludwig. Mr. Ludwig will be introducing the speakers formally. Thank you.
Thank you, Mr. Karthikeyan. Always nice to work together, especially in this program, Innovations Accelerator. Just a few words about the program from our perspective. To clarify, the criteria for the actors we are introducing from the Swedish side, we're looking for companies or innovators that is in the front of whatever technology area they're representing, cutting-edge technologies. And we expect them to have a dedicated interest to work in India and also share their experiences from whatever they represent technology-wise. And the kind of companies, obviously very often this kind of companies, innovation companies with cutting-edge solutions, very often it's small or micro size companies, but there's no limitation. It could of course be medium-sized companies. The main criteria is cutting-edge solutions and of relevance for India. So why is the Swedish Energy Agency doing this? Well, we have the mission to work for the development of a sustainable energy system. As part of that, we're the largest funder of energy-related R&D in Sweden. and the consequence of that is that we also work with the commercialization of the new technologies. And that is because many of the Swedish innovations and inventions has their greatest potential to affect the energy system in other contexts than in Sweden. So therefore, this is also included as an important thing, part of our international work, and here in India. And we have learned during the years of working in India that there is a slight barrier between the two countries, between actors. Although actors from both sides have an interest and an understanding that they would like to interact, both sides have a challenge and a barrier to find each other. And it's not only from the Swedish side approaching India, being a large country, also Indian actors have a challenge finding the right counterparts and solutions in Sweden. So we aim to bridge that, and our part is to identify the interesting companies, innovators, entrepreneurs in Sweden, and CII is covering India with the same mission. And now I'm very happy to introduce the company Exeger. They're working with third generation solar cells, a very interesting technology that can be find a huge variety of applications. And I'm not sure who will be the presenter. It should be Georgios Foufas. It might be that we have another gentleman coming in. So I hand it over to Exeger. Hopefully Georgios is here.
Yeah, Mr. Ludwig, he's very much here. Thank you. Yeah, Mr. Ludwig,
yes, I'm here. This is Georgios Foufas from Exeger. I'm the head of business development here in Sweden. I hope that everybody hears me.
Yes, Mr. Foufas, we can hear you. Please go ahead. Thank you.
Okay, very good. Yes, I will give a short introduction to our company and market overview. And please interrupt me if you have any questions, or we can also save them for the end. So Exeger was founded in 2008 by Mr. Giovanni Feli. Giovanni is a serial entrepreneur, and he is mainly invested into real estate. And during his several hotel projects here in Scandinavia, he found an interest in PV. The second person who entered Exeger was Mr. Dr. Henrik Lindström. Henrik is one of the pioneers in the field of DSC, dye-sensitized solar cells. Dr. Lindström was the first one to replicate the original foundings of the inventor of the technology, Professor Grätzel. Dr. Lindström was also the first one to invent the flexible solar cell. Dr. Lindström is one of the top 3 within the DSC research in the entire world. So as I mentioned before, Exeger was founded in 2008, and we have 2 different patent families in the company, one for transparent solar cells and one for non-transparent solar cells, which we call HEFA, high efficiency application. The most important thing here on this slide is probably down in the right corner, our operational vision, which is that a 200 megawatt factory of our technology should not cost more than 30 million euro to build. Then you would need a ingot, wafer, cell, and module than euro. So the capex is much lower for our technology. So what is DSC? Well, I will not go into details in such a short presentation, but we can mention that we can print our solar cell on any substrate, so we can have a glass substrate or plastic, and then we imitate the photosynthesis. So instead of chlorophyll, we're using other industrial dyes, and then we use titanium dioxide. So titanium dioxide is the white in white paint or the white in toothpaste, so it's a very cheap material, and then we dip that into dye. So I will not go into detail. Those of you who are interested in more, I can provide you with more information. So the main advantages, if you compare DSC to existing first and second generation solar technology, is that you can make the cell transparent and you can make it in different colors. So this allows for the solar cell to be seamless integrated into any product, for example, consumer electronics. Because we use screen printing as production methodology, we can print different patterns, pictures, even texts, and you wouldn't even notice that the surface is a solar cell. We can make the solar cell flexible, and we can print it on glass, metal foil, or plastic. Depending on the material that we print the solar cell on, we get different durability. If we use glass as a substrate, we can get over 30 years lifetime of the solar cell. One of the great advantages with DSC is that it's less sensitive towards the light angle, so the incoming angle of the light. Because the reason for this is that the solar cell is made out of a porous material. So you can think about if you have a bucket of golf balls, then it doesn't matter from which angle the light will come, it will always hit one of the balls in the bucket. So it's also stable in all light conditions, be it smog or cloudy, or if there is dirt on the solar cell, does not matter. Another very important aspect is that the solar cell works fine in high temperatures. So if we compare to other technologies, here we have a slide where we on the right side see the different gray curves are monocrystalline, amorphous silicon, CIGS, and multicrystalline. So you see that all other technologies, they lose efficiency when temperature goes up. So normally you measure the efficiency of a solar cell with a watt peak, and watt peak means that you measure at 25 degrees at 90-degree angle towards the sun, and this is rarely the case. I mean, in India on a rooftop, you wouldn't have 25 degrees Celsius, you would rather have 55, 60, 65 degrees. And then DSC actually works better in high temperatures, the only technology that has that characteristic. We also have a lower embodiment of energy, so the energy payback time is actually for DSC about 8 months. We use no scarce or toxic materials, and there is no emissions. If we compare it to silicon, for example, we have no clean rooms, and we can scale up easily to very large production. I mean, we can scale up to terawatt, and we wouldn't have a problem finding the materials in India. We can find them anywhere on Earth. Since we use screen printing is used to print T-shirts or similar things. So it's a really simple production technology. We put our dye and our titanium dioxide into the printer. We print several layers on a substrate. We heat them, and then we print again. So it's a really simple production technology that could be utilized, especially in a country like India. Here we see an example of what a DSC solar cell could look like. These are 4 lights actually made by Sony in Japan. So you can see that the solar cell itself can have different colors and different patterns. In this case, there are flower leaves. So these lights are actually self-sustaining. There is a battery inside and an LED light, and the battery is then charged by the DSC solar cells, both from the LED light and from the surrounding light in the room. So Exeger is mainly in the first step looking to enter the consumer electronics market. There are several reasons for this. Probably the most important one is that for consumer electronics the demands for lifetime is lower and the potential profit is much higher. At the moment we have developed a couple of prototypes, so we have working solar cells. We are building the largest DSC factory in the world here in the city center of Stockholm. And for example, I will give you an example. We have made a prototype for the Amazon Kindle. Then the Kindle itself trades for approximately $100 and the cover is about $40. So if we we have made a prototype where we include a solar cell in the cover of the Kindle, and that could power the Kindle entirely in an indoor setting at 500 lux. So of course, I mean, the value of such a solar cell is much higher per watts than the value of a normal silicon solar cell. That's the reason we target consumer electronics first. Another very large application area is AIPV, automotive integrated photovoltaics. We have cooperation with several car companies. Because our solar cell is flexible, it could be integrated into any part of a car. We could actually incorporate it also into the windows of the car. This is not the main focus of Exeger, since the car industry, as you know, have a very high demand for lifetime and very tight margins. 2 other very large application areas are BAPV and BIPV, that's building applied photovoltaics, and building integrated photovoltaics. So building applied is everything you can add on an existing house. So for example, a rooftop, internal blinds, external shading, or things like that. And building integrated photovoltaics is when you build a house and, for example, the window could be a solar cell, or the glass facade could be a solar cell. And then the question is, what is the cost of the window and what is the cost of the solar cell? This is a huge market that Exeger will tap into. We have a couple of prototypes also in this area, and the last large application area that we look into is power plants. This of course will take a couple of more years before we will enter this market segment. There is a very high demand for lifetime and different certificates, so this will be our last target market. If we look at Exeger as a company, we have cooperation with several academic institutions all over the world. For example, with the inventor of the DSC solar cell, Professor Michael Grätzel in Switzerland. We have raised in total approximately $30 million since we founded the company. One of our biggest contributors is the Swedish Energy Agency. We have also received money from the European Union and from different governmental organizations in Scandinavia and Sweden. One of our largest owners is a company called Fasadglas. It's a more than 100-year-old Swedish facade glass company. We also have a cooperation with Ericsson, as you all know, and another one of our owners is Wallenstam, which is the biggest Swedish real estate company listed on the Stockholm Stock Exchange. In addition to that, we have several companies which we have cooperation with, which we develop prototypes together with, which I will not mention in this short talk. Here I can just briefly show you last year in Barcelona, we showed our transparent solar cell in cooperation with Ericsson. So Ericsson, they have made a transparent antenna, and then this antenna needs a power source, so they thought it was great that our solar cell could work as a power source for their transparent antenna. This is a picture that shows the difference in design with our technology compared to existing technology. So, our solar cell could be integrated into any surface, since we can print it on plastic or metal foil or on glass. You wouldn't notice the solar cell. Here we see a rooftop made out of silicon solar cells. This is how it would look like with our solar cell. So we can choose transparency level and we can choose color of our solar cell. This is a company, here we see a picture from, this is a prototype made by Tata Steel. So Tata Steel, as you all know, is a very large Indian company. They bought British Steel a couple of years ago. They are selling approximately 120 million square meter of steel rooftop every year. And they have a small pilot plant where they actually produce DSC solar cells, which you can see here on the picture. So our factory is much, much bigger than theirs, and you see all these lines in the solar cell. This is because the conductive layer in their solar cell has a very high resistance. So our resistance is approximately 1,000 times better. So we could make one entire solar cell there without any need for any silver lines. But this shows the potential and the market size. We could cover all rooftops in different areas with our solar cell. Here we enter another market segment. Since our solar cell is lightweight, it's flexible. We are talking now to, actually we have some initial talks with the Indian Army. We also are talking to different companies making military materials. So our solar cell is perfectly fitted to be used in helmets, tents, camouflage nets, or sleeping mats. It's not so practical to carry around a silicon solar module, so it would be better to use our module, or our solar cell, which we see in the left bottom corner. The market is actually already there, so we don't have to invent the market. Here we see a couple of pictures of existing products. All these pictures are from the American Army. So we see foldable mats, we see tents. The main technology used in these pictures is amorphous silicon, which we know that we beat under these environmental circumstances. So we don't have to invent the market is already there. So to make a summary, the company was founded in 2008. We have secured in total more than $30 million in funding. We are now building the largest factory in the world here in the city center of Stockholm. It's a 15 to 20 megawatt production facility. And we are going to scale up as soon as we have the production running here in Stockholm. We're going to scale up and build large factories around the world. And India is one of our target markets. So in order to do this, we will of course raise some more money in the future. that was all from my side here. Now I'm happy to take some questions if anybody has questions.
Thank you, Mr. Yogesh. Prasanna here.
Thank you.
Sir, we would just like to understand first thing is like when we use DSC facades, how is it comparable with double glazing in terms of its UV and solar heat gain coefficient?
Could you repeat the question?
What I mean to ask is like when we use this DSC facade, what's been mentioned by you right now, how is it comparable with double glazing glass in terms of its UV and solar heat gain coefficient?
Yes, I mean we can, as I mentioned, we could print our solar cell on a glass substrate, and depending on the color that we choose, the darker the color, the higher the output we get on the solar cell. As I also mentioned during my presentation, we are in this first step mainly targeting consumer electronics. So we do have a project for the facade, also for glass facades, but we are mainly targeting consumer electronics now in the beginning.
Okay, that's great. Coming to some market-oriented questions, if we just want to understand that what is exactly your target market in India in terms of industry sector or your expectations in India when you're visiting here in April. So can you just brief us on that?
Yeah, India is a huge market, and there are, our solar cell could be printed. For example, we could produce flexible mobile chargers, so we can provide electricity to the rural areas of India. So to people who don't have electricity, we could give them a solar cell to charge their phone or an indoor light, because our solar cell works indoor and outdoor, and it's lightweight. So you can fold it, take care of it, put it into your backpack, and take it out whenever you need it. So that's the main target. In a second step, we want also to incorporate our solar cell into buildings in India. And what we are looking for in India are strong partners with a good network. We want to establish a production facility in India. We have been in several places, but we have not chosen a partner. We have not chosen a location within India yet.
Okay, that's great. So how about some kind of financing options? Are you looking for that also, like through venture capitalists or some license agreements?
We are continuously searching for more capital. We have now money for a couple of years of more development, but since we are going to make a global expansion, we are continuously searching for more capital. So in each target market that we have, we want to find a financially strong partner that has a good network distribution, but we are also looking for pure financial partners, so people to invest into our company.
Okay, that's great. Coming towards some kind of technical specifications, what should be the glass thickness and specification for any glass, and transmissal factor?
Yeah, so mainly what we focus on is actually indoor applications now in the first step. So we want to put our solar cell on mobile phones, on tablets, computers, and indoor we don't talk about efficiency, we would rather talk about outputs. So how many microwatt per square meter you get out from the solar cell at a certain illumination. So for example, indoor normally here in Sweden by law you have to have 500 lux illumination in a working environment. So under such a light we could give the e-ink reader, the Amazon e-ink reader, eternal life, so you'd never have to charge it again. So if you take it outdoor, then it will charge much faster, so linear with the lux intensity.
Okay. How about the solar print which you are mentioning to apply in the facades? What is the lifespan of that print?
So the life of a solar cell depends on the barrier material that you use. So if we print the solar cell on plastics to use, for example, on a cell phone or an iPad, then the lifetime, actually we have talked to several producers and then they don't want a lifetime over 2 years. If we are going to incorporate our solar cell on a facade or in a window of a house, then of course we need as long lifetime as possible, and then we would use a glass substrate. And then Stockholm University, they have done research and they claim that then the DSC solar cell would have a lifetime over 30 years. So it depends on the barrier material that is used.
So it is
you can print on any material.
Yeah, so it is customized as per the material on which it is getting printed, right?
Yes, yes. And we use screen printing as a technology, so it's a simple production process. We put the ingredients of our solar cell into the printer and we print several layers on top of each other.
Okay, that's great. Coming to your comments that you were looking for some kind of rural market as well, right? So
yes.
You must be aware that India is a cost-sensitive market. So how cost efficient your products will be when it comes to the rural audience, rural part of India?
Yes, our solar cell could be made cheaper than the existing technologies available today. I mean, we use a silicon-free solar cell, so we are not dependent on silicon prices. We don't have to import any material. Titanium dioxide, which is one of the key ingredients in our solar cell, we use approximately 20 grams per square meter. And if we order a sample from a supplier, they send us 20 kilo for free. So here in Stockholm, we are able to produce solar cells much cheaper than any competitor. And going to India, scaling up, building a large factory, we expect to lower that production cost even further.
So you're looking for some of the established player in this sector, or you would like to think over with some new partner or some sort of SME and join hands with them and scale it up later?
We would like to produce the solar cell and to partner with someone, with different companies. Either we could, for example, we could sell our solar cell to a mobile phone producer, a tablet producer, or we could partner with such a company. But we don't want to lock in. I mean, we want to sell our solar cells to all producers of different technologies, so not just to Apple or Sony or LG, but to all of them. So there are local producers in India. We would be happy to deliver our solar cells to any one of them, but we will build a factory together with a local partner in India and not limit ourselves to a specific market player or to a specific market segment.
Okay. What would be the approximate cost per wattage the solar PV module up to 100 watts?
Yeah, so if we talk about solar modules for power production, this is a market segment that we will not enter in the first phase. So that will take a couple of more years before we go to that market. in the first step we will target consumer electronics, and there you don't talk really about price per watt. As I mentioned an example during my presentation, we have a prototype project with Amazon and their Amazon Kindle, and as I said, that the cover for the Kindle retails for $40, and then we asked them how much would they could they sell the cover for if they have a solar cell on it, and they said, well, at least the double. So you get $40 more for the solar cell, and that's approximately 5 watt. So you have a couple of euro or a couple of dollar per watt. So there is a really, really high margin, and the cost for production for us is much, much lower. To produce a solar cell for an iPad or a Kindle would cost us roughly $1.50.
Okay. So basically you're not looking for any established player in the solar market who manufacture solar cells or solar panel, but you're looking for some of the products on which this printing can be used and make it as a basic solar cell, right?
Yeah, so I mean we don't actually have a specific demand on a future partner, rather than that they should have a good network and be financially strong. It's good if they have a sales network all over India, but they don't need to work with PV, because our technology is completely different from the existing PV industry. So it's a new product. So it could be a company that works with a completely different technology or a different market.
Okay. One more question is like, have you already developed applications that you aim to introduce first, or you would like to develop any of new one together with a partner when you find in India?
Could you repeat the question?
The question is, are you having any product in your mind, like you would like to launch this product in India first as a market entry along with a local partner, or you would like to develop a separate altogether a new product when you find a partner, relevant partner?
At the moment, we are producing. We are looking into different prototypes. So what we are mainly looking into at the moment is, as I said, to build prototypes for e-readers, so iPads or similar, and also to wearable electronics, wristbands that measure how many steps you take, how you sleep. This is the future. So in India, we could think that e-ink readers would be very good. I mean, they could be given to children in schools or to people studying at universities who don't have access to electricity all the time. They would have an e-ink reader that would always be charged with solar. Or we could make a mobile charger, so that I mean, then we're looking at a really, really big market in India. We also want to enter the facade industry, so to make solar cells for facades. But the first target market is consumer electronics, and the second one is facade and windows.
Okay, that's really great. How about any limitations which you've related to your technology, which you see through first in terms to approaching rural market or urban environments separately?
Any limitations? Well,
yes.
We can actually optimize the solar cell depending on where it shall be used. So we can choose the ingredients to choose a dye that is optimized for specific usage area. So if we want to build a solar cell that is to be put on a cell phone or an iPad or similar, we will choose one die. If we want to build a solar cell that's to be put on a mobile phone charger that you will carry outside, so in rural areas, we will use another die. So, and depending on, I mean, I would guess in rural areas of India, people would want a really, really cheap solar cell. It doesn't matter if it doesn't work more than 1 or 2 years. If they can buy a new one, and if the price is really low, then we can use really cheap barrier materials, so cheap plastics, and make a cheap solar cell that works fine, but it won't last long. And it's not toxic, it's not dangerous to just throw in the garbage, or to, yeah, you can just buy a new one. So low price products, that's what I think is mostly suitable for India.
Yeah, that can be a USP of your product as well. Coming to one more question is like, are you looking for any end customer market, or are you looking for only business partners in India?
We are, I mean, it depends. We have been in India a couple of times. We know that building relationships in India take a lot of time, so we are not rushing it. We're open for discussions in both those alternatives, actually. So we want to establish ourselves in India, and we are going to do it, and it will take the time that it takes. So we're open for suggestions.
A technical question here is like, which technology is better, mono or polycrystalline structure in India?
Yeah, mono or poly, that's a crystalline. Our solar cell is completely crystalline free, so we use a completely different technology. So our solar cell is the 3rd generation technology, and mono and poly are 1st generation. So I'm not sure I'm the right person to answer which is best, mono or poly. I mean, that changes. I actually used to work in the silicon industry before, and some people prefer mono, some poly. I would say neither one of them, and go for DSC instead.
Okay. Then what are the timelines you have in mind for entering in the Indian market, that is production and the manufacturing facility?
So at the moment we are building our pilot plant here in Stockholm. We expect that later this year, maybe by the end of the year, we will have the production up and running. According to the plan that we have, we shall have start to do some large-scale production by 2016. So there we will do commercial prototyping in 2016. And by then we would like to have found a partner in India, and when the concept has been proved here in Sweden, we will build larger factories around in the world. And India is one of our target markets, as I mentioned. So we still have time. So minimum 2 years before we would have a factory in India.
That's really great. As this is a new technology, and so is LED, so are there any specific benefits in combining the two? Have you ever given a thought on this?
Well, it's certainly possible. LEDs can be made really small and consume small amounts of electricity compared to an ordinary light bulb. Our solar cell could be made very, very thin. It's flexible, it's lightweight, so it sounds like a good fit. One thing we are looking into is remote sensors, for example. So in today's society, everything is to be connected to the internet. So you're not your cell phone and your computer, but your refrigerator, your fire alarm, your security system, and everything needs batteries and light, of course. So we don't have any cooperation with any LED company or we don't want to limit ourselves to a single market segment. But it's certainly a good idea.
So given an option, would you like to have any kind of meetings with such kind of LED manufacturers?
That could be, it could be interesting, yes.
You won't limit your discussions with only your applicant-related audiences. So you are open for the discussions with LED manufacturers as well. That's really great from your side.
Yes.
Coming to some sort of environment-friendly raw materials, the raw materials which you use, we would just like to understand how are those environment-friendly, or when it comes to the time of disposal of those materials or the end product, is it environment-friendly at that time as well?
Yes. As I mentioned, we build our solar cell mainly with titanium dioxide and different inks. So titanium dioxide is environmentally friendly, and it's available everywhere in abundance. So it's a really cheap material. Our entire solar cell is made out of environmental friendly materials which we can source anywhere, and we can scale up to terawatts easily. So it's really suitable for a country like India. It could in the future make India independent, energy independent, so they don't have to rely on China to import silicon in order to produce solar cells. So titanium dioxide is available everywhere. It's cheap and it's environmental friendly.
That's really encouraging to listen from you. Thank you, Mr. Georges. That was a really wonderful presentation and really fruitful discussions for me personally, as well as the industry members who have joined us as participants for this webinar. And we look forward for you to come back to India in April and have a fruitful discussion over the business matters.
Thank you very much. It was my pleasure.
Now I would request Mr. Ludwig to take on the charge, please.
Thank you, Prasanna. I think this was really interesting and encouraging, and actually I've been following this company on their journey in India for some time, and I think it's really encouraging and interesting. I'm looking forward to coming to India in late April to see how it develops and continue this process. And now I look forward to listen to Mr. Claes Ståhl. He's representing another solar-related company. It's a little bit more proven technology, I would say. So it's a little bit of a different perspective. So I hand it over to Mr. Claes Ståhl and to give an introduction of the company S-Solar.
Claes Ståhl. Good afternoon to all of you. My name is Claes Ståhl, and I am the CMD and the key owner of S-Solar, maybe more frequently recognized under its brand Sunstrip. The Sunstrip brand has been operating for the last 30 years and recognized in various parts of the world. Sorry for the flipping too fast. S-Solar is a privately, myself and a number of key investors from the UK, from England, with main focus on renewable energy. And the S-Solar company was created as a holding company in 2007, acquiring the Sunstrip company that had been operating for the last 30 years, specializing on coating. Today, the S-Solar company is a leading company for solar energy technology, focusing on solar thermal systems, which means hot water, heating and cooling. So I will initially be precise on that we do not work with the photovoltaics technology, with the exception that we can complement the photovoltaics technology by cooling the PV panels. But our main focus is solar thermal systems and technology for heating and cooling. We have, since many years back, been a 95% export company out of Sweden. We have customers in more than 20 countries, a couple of joint venture companies co-owned and operated in parts of the world. And our coating has and is holding a 5% global market share. And the backbone of the company is high performance, larger installations, of which we participated in more than 50% of the large installations currently in use in Europe, and some flagship key references in other parts of the world, including the Qingdao Olympic Village in China, and recently the largest solar cooling plant in the world in Singapore University. We use as a business model some key industrial partners in the European Union, of course, in Latin America primarily, in South Africa and parts of Asia, and recently we have put our focus on India. We use the partners both for distribution and R&D. Sorry, there seems to be some sort of misperception of the slides here. I apologize for this. I will try to fix this. Let me finalize this slide then by explaining in what areas the company operates. As mentioned, the backbone of the company is coating and heat transfer technology, where we have a series of proven technologies working across the world today. In addition to that, moving up the value chain, we have developed solar collector systems and panels, high performance solar panels with a good top performance in terms of energy production at a price and quality ratio attractive in most parts of the world. The last the latest but not last product line that we have invested in is the building systems, mainly responding from the market of the need of having building integrated solution into facades and roofs, using the entire surface of a facade to work as a climate shell. So we worked with some of the leading firms in the world to comply with the industry standards of the construction industry and the real estate industry. The core of our technology and our knowledge is advanced coating using the nanotechnology, and we have developed an extensive product portfolio being used and has gained a lot of interest from the Asian market, moving into new customer segments. So this is the uniqueness and the key technology of S-Solar. On this picture you may see some of our strips technology products, where we work with sustainable materials as aluminium sheets. We have our own method, and we were actually first in the world to introduce this article is selective coating process, of which the production process has been patented since 1997. The special rhombic shaped flow, turbulent flow, is increasing the efficiency of the collectors, approaching the theoretical barriers or limits of the industry. Our specialty is the metallurgical bond between aluminum and copper to have those work together in at very high temperatures. The next slide, you can see the difference. If I look at, for example, China today, the black painted absorber is being used very commonly in the market because it's straightforward and technology and could be applied easily without any large investment costs, etc. But as you can see, even though the black painted absorber efficiency is seamlessly very high, it loses in emission of the sun rays or the sunlight compared to more advanced technologies. Also referring to China, Japan, and Thailand and other countries, the anodized absorber has been preferred for some time, but now in China it's being questioned as an unattractive technology to use because of the climate impact that the anodization process has to not only to with the emissions, but also to the unfriendly working environment for people who develops this. So I think in China the directions have been to move away from the anodized absorber. The sputtered absorber that Sunstrip and S-Solar produces it has some advantages over the other types of absorbers. And briefly, the sputtered absorbers can preferably be used both in standard flat plate collectors, reflector collectors, or vacuum tubes. But where we see an increasing demand for our sputtered strips is for the high temperature and high performance collectors in both district heating, primarily industrial process heating, a growing area, also in India, what I understand, and the solar cooling applications. So for Singapore University, these strips are being used to create the world's largest solar cooling plant or installation in the world. The different surfaces being sputtered on the aluminium metal is first of all a protection layer for the metal, and then the most advanced, the 150 nanometers thick absorption layer with a composite that is to maximize the absorption of the invisible sun rays and sunlight while reducing the emission. So the performance today, using also an anti-reflection layer to prevent, is 96.5. 96% of the sunlight is being absorbed, and only 5 to 6% being emitted in emission, which creates this opportunity to go beyond the 200 degrees, even up to 400 degrees Celsius in hot water production, required for many industries. The production process patented by Sunstrip and Esolar has 3 main parts: the roll-bound part, the cleaning part of the metals, and then the batch process buttering part. It's a 24/7 type of production process, which makes it very attractive and could produce very large amounts of strips around the clock, basically. The process is then highly automated and has a technological edge to it. Moving on, I mentioned before that the investments being made during the recent years is partly going into a new type of coating. And the name of this coating is a general one. If you go into Wikipedia or any other information source, you can learn that Sol-Gel is a generic word for application of a very thin surface to change the surface characteristics and functions. The reason why we went into this together with the one of the leading universities in Sweden, the Ångström's laboratory in Uppsala, is that we recognized an increasing demand from our customers to expand and to have a more cost-efficient coating than was existing in the marketplace, and especially made for certain applications. And as the word says, it's more than just the surface. What is then Sol-Gel? It's a new type of patented coating technology. We also achieved a patent for the Indian market. That through another type of chemical process, a wet chemical process, can produce a hardened, multifaceted surface, not only for solar thermal applications, but we have done it initially for solar thermal applications. Mentioned, we have developed that in close cooperation with R&D partners, very large companies in the aluminium sector, as well as in the real estate and architecture sector. And we've used 10 plus years to develop that, and we're now ready for commercialization. This has been tested, certified, and qualified by a number of companies and testing institutions. And the technology is based on the composite being briefly described in the picture down below to the right. What are the advantages of Sol-Gel? First of all, it has an advanced quality and performance. But maybe more importantly, we have responded to some of the requirements from the market, from construction companies, building materials companies, glass manufacturers, to provide a surface that could handle different levels of moisture and heat. It has an optimized optical performance too, with a 97% absorption of the sunlight. It is also an environmental friendly production process, with basically no emissions. And very few technologies could actually say that. We're using proven coating techniques, so there's a low-risk production technology used, including a slot die technique and heating techniques. The technical platform is scalable and can be used for many different type of applications. We have now a very short lead time to full-scale production, and can ensure flexible processing of different materials, molding, bending, and coloring too, which is one of the demands from the construction and real estate industry and architects, of course, to create different patterns and bend the material in different shapes, responding to the architectural flexibility. So there are some attractive tailoring options here using Sol-Gel. Of course, the main function or the application is to create a low emission roof or facades, to reduce the need for cooling or heating of buildings. And this is what we call the climate shell function or the building envelope function. It could create a harder and more sustainable surface, also on softer materials than like aluminium, but also other types of material. It could provide corrosion protection on metals. It could react dirt, and it could be self-cleaning. And it can create a luminous, different light colors activated by UV or IR. And it certainly works as an anti-reflection surface, which makes it attractive to various industries, not only the solar thermal and building facade industries, but also to the aerospace industry, the automotive industry, etc. And it has a very low heating emission. So the heat can certainly be reused in the buildings. The concept that we work with is the climate shield, which has proven in Europe to be a leading concept being spoken about and interest gained, but also raising the demand for technologies, reducing the need of energy, and providing an attractive design feature. Also to increase the value of the building. Mentioning again China or the UK as two examples, there are a number of green building or LEED and BREEAM ambition projects in those countries, where they see that this technology will increase the value of the building which has been proven in several studies. It's also safe and economically viable long term, lasting more than 30 years, and has been extensively tested in age chambers and by independent test institutes, providing both a safe surface and economically viable, less expensive than many of the facade materials used today in high-end market buildings. If we move on to the more enhanced products, the solar panels, the solar facades, in which we plan to use Sol-Gel 2. We have laid out a new platform, like the automotive industry. We have developed a technical platform that we name Prisma, which is more than just a facade, providing the green energy. It has a high aesthetic value, and it is proven to be economical compared to traditional technology. What is then Prisma? It's an innovative facade elements that could reduce the need for energy with more than 50% by insulating the building from heating and cooling. It has a multifunction element to it, not only to protect but also to generate energy. It is also an architectural design element to create a flexible and expressive look of the building. We call it the white concept, and as you can see, this is a high-end market building in our capital of Sweden, the implementation in Stockholm. We call it the white concept, based on the leading architect firm that has been our partners in developing this. This is an illustration of how the facade could look like when an integrated solar thermal solution is used in a nice way in the building. These 4 pictures describes how an architect would use solar thermal in more advanced buildings. In more residential buildings, it could of course be used on the roofs and the facades. But we have worked extensively to make this a high-end product, high-end market product. What is then different? As being said before, the climate shield reduces the need for heating and cooling, and it replaces standard wall structures. It's easy to install since it has been developed together with key building systems and glass companies providers. And it's available both in a building systems format or a cladding version being made available for refurbishment of older buildings too. It has a long length of life, it's 100% recyclable, and comes in different sizes based on the standard nominal size. And it's a true technical platform for multiple new products. It's like a LED TV, and the difference compared to most of the solar thermal panels that you see in the market today is that it's thin. It's no more than 5 centimeters, and the weight is only 8 kilos compared to 40 plus kilos for the traditional panels. It's fully integrable Works in both new constructions and refurbishments. It's been fully certified and given Solar Key Mark tests in Europe. The Solar Key Mark test has very strong requirements and is being used in many parts of the world. It is aesthetical and ultra-thin design. You can choose choices and colors. It's patented and totally sealed, which is also different from other types of panels. It comes with montage kits, so it's easily mounted. A facade could be mounted just in a couple of days. The advantage is it's a unique product concept, reducing the need for energy. It has been proven compliant with industry standards of facades and buildings, the long lifespan, the green energy with zero emissions. It can provide a fixed low energy price for the next 30 years, independent of gas prices and oil crises. And it increases the market value of the building. From an operator or a co-owner of this, it presents a very attractive market potential. It is definitely ready for large-scale market launch in other countries. It has been confirmed by architects and can then gain interest of architects in other countries. We work with some of the leading European global architect firms already today. It has gained interest from the construction industry and real estate holders, and also from tenants. In Stockholm, there has been some requirements made by tenants to have this type of technology into office buildings. And it's patented in the main markets today, and it ensures the important points in the green building classifications. We are already now launching new collections with the new designs based on this technical platform to respond to specific project requirements. On this page you can see what I call the classical collectors, which we call the Orbit for roof and wall integration. This is an even more higher performance product related to industrial processing and similar applications. It's also very fast mounted. As you can see, it's very standardized and could be assembled in larger pieces and put on the roof or the facades. The application areas where we work the most is multifamily houses, hospitals, hotels, retail centers and malls. Official buildings have become a growing sector for us because the government wants to show that their buildings are also providing green energy. And of course the office buildings, the high-scale buildings. Some of the new products in pipeline, we're also moving indoors. We have indoor shading and climate systems using the dynamic shutters. And you can see the strips that we started the presentation with shown at the window, creating the necessary protection for the sun. Some reference projects, downtown Stockholm, a high-scale building being refurbished. Some district heating plants in Austria, the combination of biomass and solar, providing an entire city with solar energy. The largest district heating plant in the world in Denmark, named Marstal. The numbers down below doesn't really match now. It has been doubled to 36,000 square meters. Solar in India. Personally, I worked a lot with Indian companies. My background is the stock exchange industry, and I've also been one of the key owners of a consulting and outsourcing firm named Accenture, operating out of Bangalore today. The stock exchange industry, we worked extensively with HCL Technologies outside Delhi, with very long-term contracts of maintaining and developing technology for stock exchanges. That later on led to a contract with the Mumbai Stock Exchange, providing that with the stock exchange with a new trading engine. That, together with my co-partners' investment in wind power in India and our CTO's background in the nuclear industry in India, has led to that our main focus today is to find a key partner, one or more key partners in India, to not only to develop the Indian market, but also to give an India partner access to a global network that we currently have. We deliberately use the word acquisition as the common denominator of our ambitions for India. We believe India is an increasingly interesting market with the rapid growth of the solar thermal market, from the current 2 million square meters to an estimated target of 20 million square meters just in 3 to 5 years. So we're looking for a key partner to presumably set up a JV in India. What will this give a partner? It will give immediate access to superior and proven products and production technology. We're ready to move some of our production technology to India. It will get access to the Solar R&D portfolio in solar technology and production management in this area. It will also give access to new markets and revenue streams through an established customer and partner network that we have in more than 20 countries. We have an experienced board and management team, including some very key advisors, and among them a very reputable scientist out of Delhi. It could also have the potential to accelerate the growth of an SME or even a larger company in India through a strategic partnership or an acquisition of assets, or and it could accelerate and shorten the time for a higher valuation of the company and preparing for a potential IPO at one of my old clients, the Mumbai Stock Exchange. So what is Solar seeking for India? An Indian strategic business partner, either for transfer or acquisition technology, both the coating and the solar thermal technology. We could think about setting up a joint venture company with shared risks and investments. And we will also look favorably into an Indian investor into our company today that could accelerate our R&D plans for the future with the outcome of transferring that to our Indian partner. That was my presentation, and I apologize for somewhat disrupted presentation in the beginning. I don't know what happened to the slides, but I'm sure you can access this in some way afterwards. You can also look into our website, ssolar.com, to get more information. Thank you for listening.
Thank you, Mr. Klaus. That was a great presentation from you. This is Prasanna here. We just wish to understand first is SolGel, what you talked about, is a solution for harvesting energy or avoiding need for cooling?
It's a solution for harvesting energy and creating new materials for hardening and protection, and with new materials, with surface materials with new characteristics. So it has an extensive potential to move from energy harvesting to a multifunction product.
Okay, that's great. When you talked of Prisma, which is a facade type, is there any training, set of training required for the laborers who are installing it, or it's a very common installation?
First of all, I want to answer that question. That it's a labor-intensive manufacturing based on the different three major components: glass, a glass fiber back or cradle, and the absorber inside. It's being assembled by a team of 3 to 4 people, can make maybe 100 a month. So it's a very labor-intensive assembly, which makes it attractive to countries with lower labor cost than we basically have in Sweden. When it comes to the mounting of this, it's let me give you one example. We have assembled a Prisma and an Orbit roof of about 500 to 1,000 square meters in just 2 days for 2 or 3 people doing that. So it's very easily and fast mounted, including the necessary piping.
That's great. And how about its need for maintenance for systems based on SolGel and Prisma?
Sorry, could you repeat that question, please?
Okay, how about the maintenance system for the SolGel and Prisma once it's installed in the buildings?
There's basically very minimal or no maintenance. There's a 1-year checkup of the system that it works well. And usually it comes together with the remote control systems, remote supervision and control system, monitoring system, so it could be monitored from anywhere. No maintenance.
Oh, that's really great of the product. Actually, I've heard of a company, PowerBox, producing power from down to 55 degrees Celsius. So could these technologies be combined? I mean yours and PowerBox?
We have looked into that, and we have not come to that conclusion yet, but we have more studies to make in that area.
Okay, coming to a question from a building perspective, building and construction industry perspective. In India, the concept of sustainable building or green buildings is coming up really well. So we have a variety of segments from home, factories, schools, offices to as large as some townships. So how would you look your product scaling anything between small homes to big townships?
With these coating that we have identified the industrial processing as one of the key target segments, and that's a growing sector in India, using a lot of hot water. So the industrial processing sector is very interesting, and the synergies with and match with our technology is high. Another area is, of course, the hotels, hospital, the tourist sector, where there's a growing interest and demand for having zero-emission technologies embedded as a part of the buildings and the way you market the companies owning these plants. So I would see large hot water users and cooling users as hotels, hospitals, maybe schools, of course, but also multifamily houses to that extent that that they are quite new, so it could be applied in the new construction. But primarily the industrial processing sector has the greatest benefits of using our technology, and especially the STRIPS products will work well in the high temperature area. Sol-Gel is also tested to produce 500 degrees of heating, which makes it a top-notch technology compared to competition in Europe and elsewhere.
That's excellent. Have you thought of tapping rural market in India?
Not yet. We won't like to do that together with a partner, because as we stand right now in Sweden, we are not able to. First of all, we do not fully understand the requirements in the rural areas, except for medium to large scale residential houses where our technology certainly could fit. But I think we need to team up with an Indian business partner to develop special products for the residential or rural market in India.
Have you? Are you having any installations in India as of now?
Unfortunately not. We have been in discussion with a couple of Indian companies that has been testing our coating, first of all. That's where we are today. We would like to move reasonably fast, finding a good matching partner, and would thereby be willing to start transferring the knowledge and technology, and to get to a setup of co-investments.
Okay. When we understood from you about your types of acquisition that you're open for, JV or technology transfers, so you're looking towards the local productions. Am I right?
Yes. Yes. Absolutely.
So you're looking for production from the very beginning of your product when you launch it in India, right?
I think some of the coating we could initially produce from Sweden to get the products established and so on. But I think the vision that we have is to maintain the Swedish operation as an R&D center with some manufacturing capabilities for the upcoming years, while establishing a stronger base in India, not only for the Indian market, but also for export to countries where we are not cost effective, like the Mid East and African markets and also nearby markets in Asia.
That's good. I've mentioned earlier as well that India is a cost-sensitive market. So how are you looking for the cost optimization or cost economics for your product?
After doing some analysis, we believe that the material cost and the labor cost will be far much lower in India than we have today. And we also have confirmed that most of the materials that we need for manufacturing our products are available in the Indian market. So we think that it would be ideal to have a factory and together with a partner company with a solid distribution network, which is the other key criteria for us in our partner search. Manufacturing is one side of the coin, and the other one is the customer base and distribution capabilities. Well, we are not. We would be also evaluating an SME on the rise, or assuming that we can agree on the setup and the plan for the future. And we are truly interested to create a growth company, also with the potential of being listed or on the Mumbai Stock Exchange.
Okay. It seems that you already have some experience or talks in India. So are you having any kind of partners or potential companies who you feel that, okay, talking with would be a potential business case?
I think it's too early days to make such conclusions. So we are looking forward and would like to invite other companies for discussion. Now we are in the learning mode on what type of more detailed technical requirements do we need to reflect upon, and but we would welcome new companies for discussions.
You're open for discussions as
Absolutely.
a part of the right.
Absolutely.
That's really great. So are you ready to work with SMEs, because those are the ones who are capital sensitive? So working with SMEs, that indicates that you should be ready with some kind of funds on your hands to support them technically as well as financially.
Yeah, I would assume that some of the funds will come from India too, to create a solid foundation of the company.
So you're looking for some financial support as well through venture capitalist or equity market?
I think that is also interesting to us, especially if we are going to build a strong Indian company with a sustainable, competitive Indian company. We would probably need some strong Indian investors.
Okay. Is there any particular site in India which is specifically in your mind to set up your production activities?
We looked at, my experience comes from, of course, Mumbai and the Delhi area. I think we are looking, if we look at coating, I think what I understand that there's a thin film or nanotechnology center in Hyderabad, and I think that is an area where we have specifically looked into due to the competence in coating and thin film that is available there. But otherwise, we are quite neutral to this. We have experiences from Chennai and, of course, myself from Bangalore and from Delhi. So I think it needs to be a location effective in terms of distribution and access to the right skills. So I think we would like to see what kind of companies that are interested in our technologies, and then we can work out a solution on the location.
You mentioned the location. One of the location is Chennai, right?
Yeah.
So any players you're in talk with in Chennai? Is it like purely a business visit or a customer one?
It is too early, and I do not want to comment on the current discussions that we do have. But I think we have been involved in an energy project in Chennai through our CTO before. So I think all these cities are very big cities to us. So we do not necessarily need to be represented in a big city. This could preferably be set up in the rural side or a smaller city too. So the question is, I'm unable to answer your question at this point due to the respect of potential interested parties.
Okay. You must be aware that India is having lots of universities which are very good at research, and some spin-off companies are doing well in India. So are you looking for some R&D institutions as well, or universities to tie up with to elaborate more on the research part?
We will also reflect on the R&D centers, yes, if they are available. And we do have one contact. Let me just get the name right. I'm need to apologize myself at this point, but the contact that we have is a Professor Dr. Sanjay Mathur, and apologies for not expressing this right again. I think he is engaged both in the Colonia University in Germany and at Hyderabad. But as said, we're quite open to the location and are looking forward to discussions with interested parties.
So while having discussions with the potential partners, what would you place as your requirements with them as a first step to enter in India?
We will be looking into speaking to companies with core business of solar thermal or PV companies with ambitions to broaden their business into solar thermal technology. That's one category of partners that we're looking into. We're also looking into glass manufacturers and facade materials producers. That's the second category. The third category is, of course, larger companies that owns both construction companies, building new areas, etc., including the project management practice.
Okay.
And the fourth category is a sole investor with an interest, of course, to create different combinations of companies based on the SLR business to build a more of a green field or a new company, a new co. But with a strong investor. I'm just going to use some names. I know that Tata is investing in this area. I know that there are other companies that we have been speaking to that has an interest to invest in this area. So first category is solar companies. Second, glass or facade manufacturers. Thirdly, construction companies with their own production of building materials. Fourthly, an investor with ambitions to develop business in this area. But the main criteria are as follows. A good core skills in energy technology. Secondly, of course, a basic production site would be preferable to start with some experience either in coating or solar panels. Thirdly, of course, there needs to be a certain size, and I cannot say what size we would be interested in, but a medium-sized company would get some advantage in our discussion, of course. And fourthly, some funds and customer base and assets to make available. On the other hand, we will also then transfer our key technologies that we invested over the last year, like 15 million euros in. And we will also invest our distribution and customer base network, especially in developing countries. So it will be a true partnership approach to be used.
Okay. As per my understanding about the Prisma and Solgel, the Prisma says that it needs some panel installations as well, and so you might be needing some anti-corrosion technologies as well. Is it so?
Not necessarily. It's fully protected right now for corrosion, and it's fully sealed, the Prisma. So we experience in the installations that we've had for the last 30 years, with a very, very few exceptions, no corrosion problems.
Okay, because as you said, it's steel, it's fine, but in Hyderabad, we actually have 2 rainy seasons here. So corrosion is one of the problems we usually face here. So how are you planning to tackle this in a city like Hyderabad?
It's totally insulated, and again, the Prisma consists of a glass and a glass fiber cradle on the back. Inside the absorber is the engine of this. These 3 pieces are being put together and sealed and glued together with no possibilities of getting any impact of rain or moisture or dust or anything. That's the advantage with the Prisma compared to the older generation of solar panels, which were not totally sealed from humidity, moisture, and dust.
How about acid rain then? Is this technology get affected by acid rain?
We have tested it, maybe not to the most exclusive acids, but in the areas we have tested it and in the laboratories, they should let me answer this way. The glass that we are using and the backside we are using, the backside is being used by the automotive industry, and therefore it's being used under lorries and other types of vehicles. So it would probably stand most of the assets. But I think I'm not ready to exclude any assets today. But the glass and the glass fiber on the back and a totally sealed panel makes it as protected as any other facade materials today. So it's very comparative to other facade materials made of glass.
Okay. About the Sol Gel technology you mentioned, what would be the life of this gel?
We have tested it now in 8 chambers since the product has not been tested during the 20 or 30 years. But what we see of the tests in 8 chambers, I think we are more approaching 40 and 50 years. But we leave guarantees for 30 years.
30 years for any kind of environment? Let it be more sunny or more rainy? Anyone?
It's a general guarantee.
A general guarantee, common for all kind of environment. Okay. Any glass specification you would like to mention for your Sol Gel technology here?
Oh, you can use various types of glasses. So I would look into the height of the building for the thickness of glass to grow with the height of the building, and of course, if you would like different screen prints, the requirements on glass are different. So it varies is the best answer I can give today. But glass could be bought in India. We've looked into that.
Okay. For this Prisma technology, are you looking for glass manufacturers in India so that you can tie up to make some Prisma facades here in India?
That is a target segment for us where we should find a partner, yes.
Okay, so for Prisma, you're looking for glass manufacturers, and
also for Sol Gel, because we can use Sol Gel on the outside of the glass, creating the same type of patterns and glass and building protection.
Okay, for this application of Sol Gel, is there any specification like minimum glass size should be this much to have start working or to get this efficiency right, or it can work from any size to any size?
It can basically work for any size, yes.
So there is no specific requirement that minimum it should be X by Y size of glass or something?
Yes, and I would need to come back on that because I do not have the number exact in the back of my head.
Okay, no matter. Mr. Klaas, I would like to thank you for making such a great presentation. It was really informative and knowledgeable. And I'm sure when you are back to India in April, we will be ready with some good business partners, potential partners for you to meet with.
Thank you. Thank you all for listening.
Thank you all. I would request Ludwig if he would like to have an conclusion word.
Thank you, Ms. Prasanna, and also thanks for your excellent facilitation of the discussions. I think that this was an interesting webinar. We had two companies that exemplifies very well the target groups from the target companies from the Swedish side. They're both representing cutting-edge technologies, and they're both have a great relevance for India. and both companies also have a great openness to share their knowledge about the opportunities provided by the technology they represent. So I really look forward to work with these companies, work with Indian partners to see what can happen. And as we said before, the next time we come to India will be late April 23rd, 29th, and we will mainly be in Mumbai and Chennai. And you can also communicate with the companies over the web page, www.innovationsaccelerator. Don't forget the S in the middle. So thank you, Prasanna, and thank you to all of you for listening, and I look forward to meet you face-to-face in India.
Sure. Thank you, Mr. Ludwig. And to all the participants here, we would invite you to join us at www.innovationsaccelerator.com to have any further dialogue with any of the companies, as Ludwig mentioned. Thank you for listening to us in this webinar. Thank you. Thanks a lot.